And the different types of circuits we've been studying about the series circuits in particular, when these are working just fine, everything has the proper amount of voltage across it, has the amount of current that it calculates out to. And so as we close the switch, we know that the current begins flowing. And we also are going to put a fuse in this particular circuit. So we have F sub 1, this is S sub 1, and this is R sub 1, and V sub 1. So, as we work at this particular circuit, if this resistance were to decrease too far, it actually would cause this fuse to open. So we're going to take a look at what we're going to call shorts. Shorts have the characteristic of drawing much more circuit current, and as a result of that, oftentimes open up fuses. They could even cause some melting on the wire conductors, but as we take a look at these circuits, we're going to define what is a short. And for right now, a common short is just the circuit resistance is in the process of decreasing. In the case of what we call a dead short, it means that the resistance part of the circuit has already decreased to a point where it's close to zero resistance. So a dead short is approximating almost zero resistance. This is not to be confused with what we call infinite resistance, very, very high resistance to what we call an open circuit. We're going to study that in just a moment. So if this is in the process of shorting, it means that the circuit current is in the process of increasing, and what that's going to do is it could cause this particular device to heat. Whenever shorts are occurring, they usually cause the element inside of the series circuit, whatever it is, to begin heating as well because of the increased circuit current. That means the power dissipation is going to increase, and it could literally just take out the circuit itself. It could take out the device. It could possibly ruin the contacts on the switch. Usually, in most cases, depending upon how this is sized as a fuse, it usually will open this. So, and when we have a dead short, as soon as the switch is closed, the fuse should open instantaneously. Let's take a look at to see what happens when we have what's known as an open in the circuit. With regards to an open is continuing to increase in the circuit resistance. In this particular case, the current is not going to be going up, it's going to be going down. So if this is in a process of opening, which means the circuit resistance is increasing, the fuse is not going to be affected too much. The switch most likely not. The only thing is that whatever this particular component is supposed to do, its efficiency is going to be decreased considerably. If it gets to a point where this actually what we call an open, we're going to relabel this as it's a full open. If it's fully open, it means that there's absolutely zero current. Another name for a full open is also a complete open. And that means that there's absolutely no current flow occurring in the circuit. Like I said, it won't affect the amount of the operation of the switch. It shouldn't affect the fuse at all. But you will notice that the total amount of circuit current will have gone to zero. There will be no current in a complete or full open device.